Alright, so in this example we've got two quadratics to solve. When we graph a quadratic we have a parabola. So let's just make a little sketch of what this could be. We could have, I guess, two parabolas that look like that. We could have parabolas maybe that look like that. We could have a parabola, let's see, they both have the same positive leading coefficient. So maybe they just touch in the vertex. So you get the idea that we could have 0, 1, and 2 solutions. I don't think we can have 3, and I don't think we can have 4. But it'd be interesting to see if we could and to try. All right, so I'm going to solve this by elimination. These two equations are not ready to add together because if I added them together, nothing would drop out because the coefficients of the x terms, the coefficients of the y terms are not opposite each other. So I'm going to multiply one of the equations, and I'm going to choose the top equation, and I'm going to multiply it by -2. And the reason I chose -2 is because if I multiply the x squared by -2, obviously I get -2, but when I add it to +2, those two terms disappear. So that would be just great. So let's solve that. Or let's multiply by -2. So I have -2x squared, and then I'm going to have a -4y, and I'm going to end up with -30. And then all I want to do is recopy my other equation over here. So they're all nice and lined up, ready for me to add together. The x squared terms disappear. When I add the y's, I have -5y. And then when I add the -30 and the +10, I get a -20. And I divide both sides by -5. And then I get y equals 4. Alright, this is slightly deceiving because we got one y. You might think we have one solution, but we will not. Let's put this y back in one of these equations, and it doesn't really matter which one I pick. I'm just going to pick the one at the top. The x squared plus 2y equals 15. So y is 4. Let's go ahead and substitute that in. So 4 goes in for y. We have 15. So we have x squared plus 8 equals 15. Subtract 8 from both sides. We have x squared equals 7. And then we square root it. And when we do that, we get x is plus or minus the square root of 7. So I have x equals positive square root of 7. So I can make an ordered pair out of that because the y is 4. I also have x equals negative square root of 7. So I can make an ordered pair out of that. So there's my two solutions right there. And both of them have the same y coordinate, which kind of makes sense because of the symmetry of a parabola. Two solutions there, and we solved that one by elimination. So that's the end of this one.